In this video, we're going to focus on finding the dot product of two vectors. So let's say that we have vector A in the form axi plus ayj. The x component is associated with the I value, and the y component is associated with the j value. And let's say vector B is in the form bxi plus byj. The dot product of A and B is ax times bx plus ay times by. So basically, you need to find the product of all the x components and the y components and add them up together. So for this example, ax is 3, bx is 5, ay is 4, by is negative 2. So you got to multiply the numbers in front of the I values next to each other and the numbers in front of the j values together, and then get the sum. 3 times 5 is 15. 4 times negative 2 is negative 8. 15 minus 8 is 7. So therefore, C is the right answer. So now it's your turn. Go ahead and calculate the dot product of these two vectors. So we can see that ax is 4, ay is negative 7, bx is negative 2, by is 3. So the dot product of a and b is going to be ax times bx plus ay times by. So it's 4 times negative 2 plus negative 7 times 3. 4 times negative 2 is negative 8. Negative 7 times 3 is negative 21. And these two numbers add up to negative 29. So therefore, D is the right answer in this example. Now let's say if we have a vector that has 3 components as opposed to 2. So let's say A is 5i minus 4j plus 3k. And B, let's say it's 7i plus 2j minus 8k. Find the dot product between the two vectors. So it's going to be ax bx plus ay times by plus az times bz. So that's how you could find the dot product of these two vectors. So ax is 5, and then this is ay, and this is az. And here we have bx, by, bz. So ax is 5, bx is 7, ay is negative 4, by is 2, az is 3, bz is negative 8. So now we just got to do the math. 5 times 7 is 35. Negative 4 times 2 is negative 8. 3 times negative 8, that's negative 24. Negative 8 minus 24 is negative 32. So this is equal to 3. Now let's work on another example, but slightly different from the previous one. So let's say if we have 3 vectors. Let's say A is 5i minus 4j, and let's say B is 7i plus 8j, and we're going to have another vector C. Let's say C is 3i minus 2j. What is the value of A dot B plus C? Go ahead and find the value of that expression. Feel free to pause the video. Now the first thing we should do before we use the dot product is we should find the sum of B plus C. All we need to do is add them. B is 7i plus 8j. C is 3i minus 2j. So we need to add up the x components. 7 plus 3 is 10. And also the y components. 8 plus negative 2 is 6. So B plus C is 10i plus 6j. So now let's find the dot product between vector A and vector b plus c. So we need to multiply the x components of vector a and b plus c. So we're going to have 5 times 10 plus, now let's multiply the y components of vector a and b plus c. So it's going to be plus negative 4 times 6. 5 times 10 is 50. Negative 4 times 6 is 24. Negative 24, that is. And 50 minus 24 is 26. So that is the answer, positive 26. Let's go ahead and work on another example. Let's try 3a dot b. Go ahead and work on this example. So what is the dot product between 3a and b? First, we need to find the value of 3a. So we have the value of a. It's 5i minus 4j. We just got to multiply by 3. So this is going to be 15i minus, and then distribute the 3 to the 4j, so that's going to be negative 12j. So that's 3 times a. You just got to find the scalar product of a and 3. Now let's go ahead and find the dot product between 3a and b. So let's multiply the x components. So we got to multiply 5 and 15. I take that back. We need to multiply the x component of 3a with the x component of b, because we're multiplying 3a and b. So we're not going to use just vector a. So the x component of vector 3a is 15. The x component of b is 7. The y component of 3a is negative 12. And the y component of b is 8. 15 times 7, that's 105. 12 times 8 is 96. 105 minus 96, that's 9. So that's the dot product between 3a and b. Now let's work on one more example. Find the value of 4 times the dot product of a and b. So this one is not difficult. So first let's find the dot product of a and b. It's just going to be 5 times 7. We're going to multiply the x components of the two vectors. And then negative 4 times 8. And then whatever that result is, we're going to multiply by 4. 5 times 7 is 35. 4 times 8 is 32. And so that's 3. So it's going to be 4 times 3, which is 12. So that's the value of 4 times the dot product of a and b. So let's say if we have a vector a, and let's say it's 3i plus 4j. Find the magnitude of vector a. The magnitude of vector a is simply the square root of the sum of the square of the x components and the y components. So in this case, it's going to be the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. Notice that this is associated with the 3, 4, 5 right triangle. Let's say if we were to plot the vector starting from the origin. 3i, that's the x component. So basically, to get that, you need to travel 3 units to the left. To the right, not to the left. The y component is 4. So we need to go up 4 units. The magnitude is basically the length of the hypotenuse of this right triangle that's formed. And based on the Pythagorean theorem, it's going to be 5. So the magnitude is always the hypotenuse of the right triangle formed. Try this one. Find the magnitude of vector b. Let's say it's negative 7, 24. Go ahead and figure this out. If you're familiar with your right triangles, the special right triangles, you know the answer is 25. Here's some numbers that you need to know. There's a 3, 4, 5 right triangle, the 5, 12, 13 triangle, then there's the 8, 15, 17 triangle, and also the 7, 24, 25 triangle. But for the sake of practice, let's just go ahead and do the math. And let's graph it relative to the origin. So the magnitude of vector b is going to be the square root of bx squared plus by squared. And we can see that -7 is the x component, 24 is the y component. So this is going to be the square root of -7 squared plus 24 squared. -7 times -7 is positive 49. 24 squared, that's 576. And if we add 49 plus 576, that's equal to 625. And the square root of 625 is 25. So that's the answer. Now let's find the magnitude of a vector that has 3 components. Let's say A is equal to 2i minus 4j plus 6k. So the magnitude of vector A in this case is going to be the square root of ax squared plus bx squared plus cx squared. So it's going to be 2 squared plus -4 squared plus 6 squared. Now 2 squared is equal to 4. That's 2 times 2. -4 squared, or -4 times -4, that's 16. And 6 squared is 36. 4 plus 16 is 20. 20 plus 36 is 56. Now what is the square root of 56? How can we simplify that expression? So what we want to do is factor 56. We want to take out a GCF, or a factor that is a perfect square. 1, 4, 9, 16, 25, those are perfect squares. 4 can go into 56. 56 divided by 4 is 14. And the square root of 4 is 2. So therefore, you could simplify the answer as 2 root 14. That's the magnitude of vector A. Let's say if you have the magnitude of 2 vectors. Let's say vector A is 15 units. That's the magnitude of vector A. And the magnitude of vector B, let's say it's 8 units. And the angle between them is 30 degrees. My picture may not be drawn to scale, but let's simply work with these numbers. Given this information, what is the dot product of A and B? Another way in which you could find the dot product of 2 vectors is you could multiply the magnitude of the 2 vectors times the cosine of the angle between them. So in this case, it's simply going to be 15 times 8 times cosine 30. 15 times 8, that's 120. Cosine 30 is the square root of 3 divided by 2. 120 divided by 2 is 60. So it's equal to 60 root 3. And as a decimal, that's about 103.92. So that's the dot product of those 2 vectors. That's how you can find it if you have the magnitude of the 2 vectors and the angle between them. Now, for the sake of practice, let's work on another example. So now it's your turn. Let's say that the magnitude of vector A is 10 units long, and the magnitude of vector B is 8 units long, and the angle between them is 120 degrees. Go ahead and calculate the dot product of A and B. So it's going to be the magnitude of A times the magnitude of B times cosine theta. So this is going to be 10 times 8 times cosine 120. 10 times 8 is 80, and cosine 120 is, well, technically it's negative 1/2. Cosine 60 is positive 1/2, but 120 is in quadrant 2, and cosine in quadrant 2 is negative. So 80 times negative 1/2 is negative 40. This is the answer. Now let's say if we have two vectors, vector A, which is 3i plus 4j, and vector B, which let's say it's 5i minus 4j. What do we need to do in order to find the angle between the two vectors? To find the angle, you can use this formula. The dot product of AB is equal to the magnitude of A times the magnitude of B times cosine theta. So we need to find theta. So it's going to be the dot product divided by the product of the magnitudes. That is equal to cosine theta. So let's go ahead and use that formula. So A dot B, the dot product of A and B, it's going to be AX times BX. That's 3 times 5 plus AY times BY, which is 4 times negative 4. The magnitude of A is going to be the square root of AX squared plus BX squared. And then the magnitude of B is the square root of, actually this is AY squared, not BX squared. I meant to say AY. So the magnitude of B is going to be the square root of BX squared plus BY squared. So this is AX, AY. I keep mixing that with BX, but this is AY. 5 is BX, and negative 4 is BY. Just to make sure everything is clear. AX times BX, 3 times 5, that's 15. AY times BY, that's negative 16. And 3 squared is 9, 4 squared is 16. 5 squared is 25. Negative 4 squared is 16. 15 minus 16 is negative 1. 9 plus 16 is 25, and the square root of 25 is 5. 25 plus 16 is 41, and we can't simplify that radical. So this entire thing is equal to cosine theta. Using this expression, how can we find the value of theta? Theta is going to be the arc cosine, or the inverse cosine, of what we have here. That is, of negative 1 divided by 5 root 41. Go ahead and type this information in the calculator. If you're not getting the answer, make sure you put this in parentheses. And make sure your calculator is in degree mode. So arc cosine negative 1 divided by 5 root 41 is equal to 91.79 degrees. That's the answer. So I'm going to write the answer here. It turns out that there's another way to get the same answer. And let's go ahead and use that technique. So first, let's go ahead and plot the vectors. Vector A is in quadrant 1. This is the magnitude of vector A. And if we turn this into a triangle, this is going to be the x component, and this is the y component. We need to find the angle theta. AX is 3, AY is 4. To find the angle theta, you can use this equation. It's arctangent AY over AX. If you recall from trigonometry, based on the expression SOHCAHTOA, if we focus on the TOA part, tangent of theta is equal to the opposite side, which is AY, divided by the adjacent side, AX. So arctan of AY over AX will give you theta. So that's why we can use this equation. So arctan of 4 divided by 3 that's equal to 53.13. Now let's do the same thing for the other vector. Vector B is in quadrant 4. The x component is 5, the y component is -4. So this is vector B. 5 is bx, -4 is by. So we got to find this angle theta. So we're going to use the same formula, but let's ignore the negative sign. So for by, we're just going to put 4 instead of -4. If you type in arctan of 4/5, make sure your calculator is in degree mode, you're going to get 38.66 degrees. So that's this angle right there. Now let's put it together. Let me just get rid of this stuff here. So vector A is in quadrant 1, as we mentioned before, and vector B is somewhere in quadrant 4. The 53.13 degrees, that's between vector A and the x-axis. And the 38.66 degrees is between vector B and the x-axis. So the angle between vectors A and B is the sum of these two angles. So if we add 53.13 plus 38.66, you're going to get this answer, 91.79. So you can also use arctangents to get the answer as well. But you may need to draw the graph to see how the two angles, if you got to add them or subtract them, and how they're going to give you the answer. But that's another way you could find the angle theta. Let's try another example. Let's say vector A, this time I'm going to write it in this form. Let's say it's -4, 7, and vector B is 3, -6. Find the angle between these two vectors. So cosine theta is equal to the dot product of A and B divided by the magnitude of A and B. You can do it separately or all together. So we know the dot product of A and B is going to be AX times BX plus AY times BY. And the magnitude of A is AX squared plus AY squared times the magnitude of B, which is BX squared plus BY squared. And let's identify our numbers. -4 is AX, 7 is AY, 3 is BX, -6 is BY. So cosine theta is going to be AX times BX, that's -4 times 3, plus AY times BY, that's 7 times -6. And then the magnitude of A is going to be the square root of -4 squared plus 7 squared times the square root of bx squared, which is 3 squared, plus by squared, which is -6 squared. -4 times 3 is -12. 7 times -6, that's -42. 4 squared is 16. 7 squared is 49. 3 squared is 9. -6 squared is 36. -12 minus 42 is -54. 16 plus 49, that's going to be 59 plus 6, which is 65. And 9 plus 36 is 45. Now let's just get rid of a few things. Let's make some space. Let's see if we could simplify what we have. So root 65 is basically 13 times 5. So we have root 13 and root 5. 45 is 9 times 5. And 54, That's 9 times 6. And 6, we could break that down into 3 and 2. You'll see why I'm doing this. Now, the square root of 9 is 3. And the square root of 5 times the square root of 5 is the square root of 25, which is 5. And notice that we can cancel a 3. So right now what we have is that cosine theta is equal to negative 18 divided by 5 root 13. If you want to, you can rationalize the radical, but let's leave it the way it is. The angle theta is equal to the arc cosine of negative 18 divided by 5 root 13. Again, if you're having issues getting the answer, make sure you put these two numbers in parentheses. If my math is correct, I got 176.82 degrees. Now let's see if we can get the same answer using arctangent. So let's graph each one separately. So the first one, vector A, we can see that AX is negative, AY is positive. So therefore, it's in quadrant 2. This is negative 4, and this is 7. So let's find the angle theta. Now, if you want to find a reference angle, which is the angle inside the triangle, make sure you only use positive values for the x and y components. So that particular angle is going to be arctangent AY over AX, that is 7 over 4. Ignore the negative signs. So this will give you 60.255 degrees. Now let's move on to the other vector, the vector B. We can see that x is positive, y is negative, and so it's in quadrant 4. So to find the angle, it's going to be arctangent y divided by x, 6 over 3, ignoring the negative sign. So the angle is 63.435. So notice that we can't just add these two values, because it won't give us the answer. So what can we do then? How should we use it? The first thing we need to do is plot the two vectors in the same graph. So let's do that first. So here's vector A, and here's vector B. Now the angle theta, in this case, it's between A and the negative x-axis. So this is 60.255. This theta is between B and the positive axis. The positive x-axis, excuse me. So this is 63.435. Our goal is to find the angle between vectors A and B. So we could find it this way, or we could find it that way. We need to find it both ways and pick whichever is smaller. Using the arc cosine formula that we did, which was the dot product of A and B divided by the magnitudes of A and B, it's going to give us the smaller of these two angles. So if you don't know which one is smaller, just find both of them and then pick the smaller one. So notice that this angle here is 90 between the x and the y-axis. Now this angle here is complementary to 60.255. So it's 90 minus 62.55. 90 minus 60.255. I said that wrong. So this angle inside is 29.745. I ran out of space. So notice that we can add these three angles to get the angle from A to B. 29.745 plus 90 plus 63.45, 0.435, that is going to be 183.18. So clearly this is the larger angle. So to find the other angle, it's going to be 360 minus 183.18. And then you get the other answer, 176.82, which is what we had before. Now let's work on an example where we have two vectors, but with three components instead of two components. So feel free to pause the video and go ahead and find the angle between the two vectors. You don't have to prove it using the arctangent formula. Just simply use the formula involving cosine. So cosine theta is going to be the dot product of A and B divided by the magnitudes of A and B. So for a vector with three components, the dot product is going to be AX times BX plus AY times BY plus AZ times BZ divided by the magnitude of A, which is the square root of AX squared plus AY squared plus AZ squared, and then times the magnitude of B, which is BX squared plus BY squared plus BZ squared. So let's write down everything. So this is AX, AY, and AZ. This is going to be BX, BY, BZ. So AX times BX, that's 3 times 6. And then AY times BY, that's 4 times negative 4. And then AZ times BZ, it's a negative 5 times 7. Now the magnitude of A is going to be the square root of AX squared, which is 3 squared, plus AY squared, that's 4 squared, plus AZ squared, which negative 5 squared and 5 squared is the same thing. It's going to be 25. And then BX squared, that's going to be 6 squared. BY squared is 4 squared equivalently. And BZ squared is 7 squared. I'm just messing up my words today. 3 times 6 is 18. 4 times negative 4 is negative 16. And negative 5 times 7, that's negative 35. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 4 squared is 16. 7 squared is 49. 18 minus 16 is 2. And 2 minus 35, that's negative 33. 9 plus 16 plus 25, that's 50. And 36 plus 16 plus 49 is 101. $50 times 101 is 5,050. So theta is equal to arc cosine negative 33 divided by root 50/50. So you should get 117.67 degrees. At least that's what I got. So hopefully I didn't make any mistakes, but that's the angle between these two vectors. That's how you can do it if you have two vectors with three components.